Hey everyone, this is the Lecture Dude, and today I'm going to talk about matrix operations. I went over this idea of a matrix last lecture, where you have just a collection of numbers in a box. Well, in linear algebra, we define that box as having, you can do certain things to it. So, it's not the same as just adding two numbers. You have to add these entire blocks. So I'm going to go over matrix addition, multiplication by a constant, and multiplication of two matrices. So to start with, we're going to go over matrix addition. For matrix addition, you need to have two matrices of the same size. The size is the rows times the columns, or rows by the columns. So for this matrix right here, I have 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So this is a 3 by 3 matrix. Same here. 1, 2, 3 rows, 1, 2, 3 columns. It's a 3 by 3. So we can do matrix addition. What matrix addition is you just take the place, each place that's the same on both matrices, and you add them together. So let's take the top left corner, the first place. For our first matrix, that answer is 1. For the second, we have 2. So 1 plus 2 for our result matrix is 3. You put that answer in the same place all the time. So let's go for the second column. Alright? First row, second column. You have a 4 plus a 5. That's 9. Then you have 7 plus 8, 15. So we filled out one row right here. Then you just do the same across the other rows. 2 plus 1 is 3, 5 plus 7 is 12, and 8 plus 4 is 12. 3 plus 3 is 6, 6 plus 6 is 12, 9 plus 9 is 18. So there you have it. That's our answer. It's a matrix, a 3 by 3, just like the 2 we added. Now, how we multiply a matrix by a constant is pretty similar. So you have a matrix, that same collection of numbers, times a single number. In this case, 3. So what you do is you take this 3 and you multiply each term by 3. So each part of this matrix will give you its own value times 3. So, of course, the answer is going to be a 3 by 3 again. So 3 times 1 is 3, 3 times 4 is 12, 3 times 7 is 21. And we do this all across all the rows, all the columns, until we have every single term multiplied by 3. So 9, 18, 27. And that's how we multiply by a constant. Sometimes you'll hear this constant called a scalar. That just means it's a single number, just a number, and not a matrix. It's one of those terms linear algebraists like to throw around. Now we get to matrix multiplication. This is actually a lot more complicated, because for matrix multiplication, you have to have certain properties. First, you have to have two matrices side by side. So we're going to make these matrices, let's make it 3, 2, 4, 1 times, there's no sign, you just put it right next to it, 5, 2, 1, 2. Now, what we do to first determine if these matrices can be multiplied is we write out the size. So this first one is a 2 by 2. Okay? The second one is a 2 by 2. What you have to make sure that these are in the right order. Because if I put this in front of this, in other words, b times a, you'd get a different answer. So, what you do when you have the size is you make sure that the innermost terms, these two, are the same. If there's a 2 and a 2, then you're good. the matrices can be multiplied. You cross those out, and you're left with what size matrix you're going to end up with, a 2 by 2. So we know already that the answer is going to be a 2 by 2 matrix. Now, what you do to determine the each entry is you have to take the first row, or the row from the first one and the column from the second one. So if I'm trying to find the first row, first column of the answer, I want to find the first row of the first one and the first row of the second one. So in this case, it's this row and this column. Then you go through and you multiply each part individually and add the result. So I take 3 times 5, that's 15, plus 2 times 1, that's 2. I add those, and that'll be my first row, first column entry, 17. I do the same for the first row and the second column. So 3 times 2, 6, plus 2 times 2, which is 4. So first row, second column will be 10. I do it for I'm going for second row, first column now. So second row, 4 times 5 is 20, plus 1 times 1. And that's 21. And last but not least, the second row, second column. So second row, 4 times the second column, 2. 4 times 2 is 8. So 8 plus 1 times 2 is 2. So 8 plus 2 is 10. And there you go. You have your answer. It's a 2 by 2, just like we said. And for all matrices, you're going to have to go through the same process. You want to find the size first, and then you want to multiply the rows of the first one times the columns of the second one. If you do that, you'll get the right answer every time.